Thank you very much. Good morning, Wolfgang. Good morning, ladies and gentlemen. Yes, I'm coming from the Austrian Central Statistical Office, where I started my work. Now we are Statistics Austria, and I remember the time when I started to work in the office in the mid of the 1980s. At this time, the VID and Statistics Austria were located in the same building, Hintere-Zollernstraße 2b, and the population division of Statistics Austria was already on the same floor like VID. So we had a lot of discussions, we had a lot of cooperations, we had common lunches, we had common celebrations of Christmas. So we had a lot of talks, a lot of discussions, and a lot of exchange. This was the time when I started. In the meantime, the VID moved, we moved, and we are now a little bit displaced, but there's still a lot of cooperations I will talk about this morning. Let me start with Statistics Austria population projections. We do it every year by NUTS 2 regions, that's the 9 Austrian Bundesländer. About every third or fourth year, a new generation of population projections is made. We do revisions for all projection parameters like fertility, mortality, and migration. In the years in between, we update these projections by the actual population figures. The last generation was in the year 2012, based on the 1st January of 2012, and now a few weeks ago we released our generation 2016, based on the population of 1st January 2016. When we discuss our population projections, we have a great group of experts where we talk about the concept and the assumptions of our new forecast generations. Of course, all of our demographers of Statistics Austria are in this group, as well as representatives from the scientific world, like the VID and universities. They look on our concepts and we talk about. Then of course also representatives from the Austrian government are in this group, for instance, ministries for social affairs. And then, of course, also the representatives from the government, of the statistical departments, from the Länder are there, because we are doing it on the NUTS 2 level. And last but not least, very important for Austria, also the chambers, Chamber for Employees, Chamber for Commerce, and trade unions are in this group. So when we're doing population projection, it's in a broad sense with all key players of users of population projections. I will now show you 5 exemplary cooperations in the fields of demographic projections we did in the last decades. Two of them were mentioned already yesterday, or this morning, yesterday by Richard Gieser and this morning by Nico Keilmann. I will talk a little bit about the project Vienna, a City Beyond Aging, the papers we have made together. Then about probabilistic population projection for Austria. We'll talk about spatial population projections, the so-called Europe projection. The first one where I was involved was a cooperation with VID as well. Then one of the most challenging projects for me, the TATSIS project, Household Projections for Russia. And then last but not least, I will talk about about Austrian population projections, how fertility and mortality assumptions are stimulated by VID. Vienna, a city beyond aging, was mentioned yesterday by Richard Gieser. There are two publications, one of the 1980s where it was published in PopNet, and then a revised paper in the Vienna Yearbook of Population. The first paper, 1987 for Austria and the 9 Bundesländer, it was based on this projection for Austria. It was presented at the JASA conference, Future Changes in Population Age Structure in Sopron in October 1988 and published in PopNet, as I said, and the revised paper in the Vienna Yearbook 2003. Here we see the results of this projection for Vienna, and in red you see the real figures. As you can see, Vienna had a rise in population much more than projected at the time before. The reasons are, of course, migration. You know, the opening, the falling of the Iron Curtain in 1990 and 1991, and then the opening to the east and the EU enlargement. So we have now a population in Austria for 8.6 million and projected at this time were 7.5 million inhabitants. Also Vienna grew much higher since this time, because 40% of the immigrants are going to the capital of Austria. So if we look to the figures by broad age groups for the city of Vienna, at least the working age population grow much higher than it was seen before because of in-migration to Austria. But if you look at the broad age groups by in percent, then you can see that the percentage of persons aged 60 plus now much lower than projected in the late 1980s. We have now 22% and we projected 26%. This is due to, as I mentioned, due to migration. The percentage of working age population became higher because of in-migration to Austria and Vienna. Also, the probabilistic population projection for Austria, mentioned by Richard Gieser yesterday and Nico Keilmann this morning. There are two papers where it was where they were published. Probabilistic population projections for Austria in the PopNet number 30 and in the Statistische Nachrichten 1997. This probabilistic population projection was based on population projection for Austria 1996. This picture you have seen yesterday by Richard Gieser, where the results of the population projection, the population projection for Austria are shown, and I will show now a little bit more, but I will show you where we are now. Due to in-migration to Austria, we are on the upper range of this these curves. You see a lot of dotted lines. They refer to different deterministic variants for Austria, and we are more or less in the line of high fertility and high immigration. Fertility did a little bit recover, as we will see later, but of course it's, as I've mentioned, it's due to more or less to in migration to Austria. On the other hand, if we see the old age dependency ratio, and this underlies what Nico said this morning, that the aging is irreversible. We have a great aging process which was projected since the 1970s for Austria and also for the European countries. The old dependency ratio, age 60 plus, divided by the age group 15 to 95, is rising, and if we look where we are now, we are, of course, on the lower range of these variations. The first time I was involved to spatial population projections was the EUROC prognose 1991 to 2021, which was a cooperation between several institutes like VID, Institute for Urban and Regional Research, both from the Austrian Academy of Sciences and the Humboldt University of Berlin. And we had also a subcontract in this project, and this was, as I mentioned, ordered by the Austrian Conference on Spatial Planning, die österreichische Raumordnungskonferenz EUROC, based on census 1991, and we were involved in data adding, discussion on assumption and variance, adapting and running the projection model and analysis. I remember I had to split up a 1-6 model, which was written in a Fortran to a 2-6 model, as we're using in population projections. One sustainable effort of this spatial population projection in the 1990s is using the Hartwiger function for estimating fertility curve by 4 parameters, like the total fertility rate, the mean age of fertility, the highest age of fertility, and the variance of the curve of fertility. This Hartwiger function, which was introduced to this population projection, is still used in Austrian population projections to estimate and project fertility curves. You see here the age-specific fertility rates in blue, the observed rates, and then the smoothed rates by the Hartwiger function. One of the most challenging projects for me was our TACIS project in the years 2005 and 2007, where we implemented a system of household projections for Russia. There was a cooperation with the WID, with Sergei Sherbov, Dorkhat Ediev, and Richard Gieser, who were involved in this project and did a lot of the work. We had to develop a new methodology facing EU standards and adopt them for Russia in order to estimate and forecast the number and structure of households. Improving quality of demographic analysis and introduction of new demographic indicators. We developed an input database for household estimates and projections for Russia. And Darkhart developed a spreadsheet program for the projecting the households by size, which was based on our old method we used in Statistics Austria. This paper you can see here was in the working papers 2007 of the VID. This spreadsheet model we are still using also for Austria in our household projections. Then we had a lot of other tasks, teaching, which was done by Sergei and by Sergei and then other colleagues from the VID for the specialists of the Russian Central Statistical Office. Then another work VID has done for us is the model we are using in our population projections to project mortality. This model was also done by Darkhart EDF, and it is based on the Carter model and should fulfill all our constraints, like at all ages the predicted relative reduction of male death rates are lower than for female death rates or equal. The relative decline of mortality must not increase with age, e.g. lower mortality predicted at age 70 than at age 60, and no increase in mortality in all ages. Here you see the slopes B observed and smoothed coming from this model as it's now in our actual population projection. And last but not least, the model for fertility projection is also stimulated by the VID and by paper written by members of the VID, namely fertility forecasting in the German-speaking world, recent experience and opportunities for improvement, which was published in the Zeitschrift für Bevölkerungswissenschaft, and we are using now the tempo-adjusted fertility approach. As you can see here, what we have done before, as many countries in the world, we underline an increase of fertility up to a certain year, and then a constant for the rest of the projection period. And also we did the same with the mean age of childbearing. Say, okay, births are postponed, they go up, the age goes going up, and then constant. And the tempo-adjusted fertility model says that the tempo-adjusted fertility model is the normal fertility, divided by a factor RT, which comes from the differences of the rising age of fertility. And what happens if you hold everything constant, the tempo-adjusted fertility would fall down to the long-term projected value. So we are now going to fulfill this model. We are looking also on cohort fertility. As we can see, that cohort fertility is much higher than the observed period fertility, and cohort fertility didn't go below 1.6 so far in Austria, so we will go up to 1.6 with our fertility, and and up to 33 years by mean age of fertility, and we will do it in a way that the model of temperature-adjusted fertility is not disturbed. Here you can see in my last slide the fertility curve of the 1970 and the actual fertility, and with these parameters extrapolated and estimated by the Hanika function, we have for the year 2080 the medium, the high and the low variant of fertility. So thank you very much and happy birthday, Wolfgang.